Assalamu alaikum, welcome back to the DSP signal processing course, and today we'll discuss lecture number 3, which is about system and its types, interconnections and properties. First of all, let's recall what system is. System is something that processes the signal to create other signal, and signal are the values that are read by sensors. So here we'll discuss interconnections of systems. When there is a node-to-node interconnection, it is called series interconnection or cascade interconnection. Its mathematical form is the output is equals to the multiple of both the systems into the first input. Okay. And parallel interconnection, both systems are getting one signal and the output will be the sum of both the outputs. Here is its mathematical form. Now comes the feedback system. In feedback system, the first system get the input from the output of the second system, and the output of the this system is the input of the first system. That's how feedback system works. Its mathematical form is shown as this. Now, properties of systems. There are certain properties of systems, that is causal, non-causal, linearity, time invariance. We'll discuss them one by one. Causal, non-causal. In causal system, we have past values. That is, you can see from example 2x and minus 1. Minus 1 shows that it is the past value. And in causal, non-causal systems, we have future values, and plus 3 shows it's a future value. System can be in this form too. We can open this form and check whether it's a causal or non-causal. In this case, it is non-causal. Second property is linearity. To prove linearity, we have to do some calculations. We have to prove additivity and homogeneous property. Okay. How can you tell by looking at the system and that this is linear? If it is a first order system, you can say it's a linear system, but still that's not the benchmark. Okay, let's do an example. In this example, we have to prove that it's a linear system. First of all, we'll let the input x1 will give this output y1 of n. Here in the input point, we'll replace it with x1 of n here, and x2 of n gives the output y2 of n here. We'll write it x2 of n minus x2 of n minus 1. Okay, so we have to prove that the sum of the inputs will give the sum of these outputs. So we'll let z of n is equals to x1 of n plus x2 of n, and we say z of n will give z of n minus 2 z of n minus 1, and here z of n is equals to x1 of n and x2 of n. So we put x1 of n minus 1 plus x2 of n minus 1. When we separate them, we'll see that it is the sum of these two chunks, and we can say it is y1 of n and y2 of n. So system is additive. Now we'll discuss homogeneity property. It shows when input is multiplied by some number, scalar quantity, the output should be multiplied with that quantity too. So here we say that alpha x of x1 of n will give this alpha y1 of n. Same with beta x2 of n, it will give beta y2 of n. So why we are adding these? Because we are proving linearity, homogeneity and additivity at the same time. Okay, let's suppose z of n is equals to alpha x1 of n plus beta x2 of n. Okay, so here we did some calculations and proved that they're equal. That is, this thing is proved. So we can say the system is homogeneous and additive and the system is linear. There is an example of non-linear system. Y of n is equals to x of n plus 5. This is easy to uh, check that if we replace it with x1 of n plus x2 of n, we cannot replace this with 5 plus 5. When we'll split it, it won't be equals to y1 of n plus y2 of n. So this is a non-linear system. Meanwhile, there is another property of linear system, sinusoidal fidelity. When input frequency is similar to the output frequency in a continuous signal, it is called sinusoidal fidelity. And when this occurs, we can say this system is linear. There is another property of systems which is time invariance. So when time shift happens in input signal, the same shift should occur in output signal. So we'll discuss mathematically. X of n gives y of n. X of n minus n naught should give y of n minus n naught. Let's suppose z of n is equals to x of n minus n naught, and z of n will give z of n plus 3. So in z of n we'll put x of n minus n naught. Okay, we can see the input change gave an output change, so we can say the system is time invariant system.